Good morning, one and all. My name is V. Abhijit Kumar. I'm studying in BTech first year, second semester, CSC, AIML, that is Computer Science and Engineering, with a specification of Artificial Intelligence and Machine Learning, Institute of Aeronautical Engineering. In this concept video of the subject of EC, that is Engineering Chemistry, the topic I've chosen is the topic of erosion corrosion. Hence, I'm going to explain completely and in a stepwise manner about the topic of erosion corrosion. So first of all, let's go through the contents which I'm going to explain in this video. In the first place, I'm going to introduce the topic of erosion corrosion, and after that I'm going to explain about the mechanism of erosion corrosion, and a lot of factors are there which completely influence the concept of erosion corrosion. I'm going to explain about them after that, and after that there are a lot of common materials affected due to erosion corrosion. I'm going to explain about them, and after that a lot of industrial examples of erosion corrosion. I'm going to explain them, and after that there are certain methods which are used to prevent and control this erosion corrosion. I'm going to explain them, and after that in the final place I'm going to conclude this concept and the topic of erosion corrosion. Now first of all, let's come to the introduction of erosion corrosion. By definition, this concept of erosion corrosion is simply a type of corrosion which involves the combined action of mechanical wear and tear and electrochemical attack. This erosion corrosion, which we are talking about right now, occurs when a corrosive fluid flows over a metal surface at a high velocity. This concept of erosion corrosion, this phenomenon of erosion corrosion is very common in factories, in industries which handle liquids and slurries. So this is the definition and introduction of this phenomenon of erosion corrosion. Now let's go through the mechanism of erosion corrosion. In the first place, the surface film or the protective oxide layer is mechanically removed. Many metals naturally form a thin oxide layer on their surface which acts as a protective barrier against corrosion. But however, in environments with a high velocity fluids or abrasive particles, this protective film can be manually or mechanically worn away. So this is the first step of mechanism of erosion corrosion which happens generally, and after that continuous removal exposes fresh metal to corrosive environment. Once the protective layer is removed, the underlying fresh metal is directly exposed to the corrosive environment such as water, chemicals, gases, etc. many more. This exposure initiates the chemical reactions that corrode the metal surface, as we can see in the image. And after that, enhanced rate of metal loss compared to pure corrosion or pure erosion occurs. The combined effect of mechanical erosion and chemical erosion leads to a synergistic interaction which results in a much higher rate of material loss that would occur from either erosion or corrosion alone. Understanding this mechanism is very crucial for industries where equipment is exposed to harsh environments as it informs the development of strategies to mitigate the phenomenon of erosion corrosion and extend the lifespan of metal components. Hence, this is the mechanism of erosion corrosion. Now let's go through the factors influencing this phenomenon of erosion corrosion. Erosion corrosion in general is influenced by several interrelated factors that collectively accelerate the degradation of materials in industrial systems. One such primary factor is fluid velocity, as you can see in the slide. If there is higher fluid velocity, it leads towards more corrosion or more damage, whatever, because higher velocities increase mechanical forces on surfaces, which strips away the protective oxide layers and expose the fresh metal to corrosive agents. Thereby, it intensifies the material loss, which leads towards erosion corrosion. The next factor is presence of suspended solids. If there are any suspended unwanted solid substances in the fluid, it leads towards more corrosion or more damage, again whatever, because the presence of suspended solids such as sand, debris, etc., it further exacerbates this effect as these particles physically abrade the metal surface, removing the protective films and facilitating the localized corrosion. It influences the erosion corrosion a lot. And temperature. Temperature also plays a higher significant role. Higher temperature accelerates the reaction rates which lead towards erosion corrosion, because this temperature which plays a significant role, due to this it happens in this way, like elevated temperature accelerates chemical reaction rates and it leads towards faster corrosion processes and it weakens the integrity of protective layers. And the next factor is the material properties of the components, which include hardness, toughness, and inherent corrosion resistance, etc. These material properties determine the susceptibility to erosion corrosion. The materials lacking these properties are more prone to damage. And lastly, the flow pattern. Turbulent flow increases the phenomenon of erosion corrosion, because this turbulent flow causes fluctuating pressures and shear stresses that disrupt the protective films and increase the rate of erosion corrosion. Hence, understanding these factors is very crucial for designing the effective prevention and control strategies to enhance the longevity and reliability of equipment exposed to corrosive and erosive environments. Now let's go through the common materials which are affected due to this phenomenon of erosion corrosion. Firstly, carbon steels. These carbon steels lack a protective oxide layer. This makes them easily corroded once the surface is worn away. And after that, stainless steels. Stainless steels have a protective chromium oxide layer that can be easily damaged. This thing exposes the metal to corrosion in aggressive and abrasive flow conditions. And after that, copper alloys. These copper alloys form a soft surface film that easily gets eroded in fast flowing or turbulent water. And after that, aluminum alloys. These aluminum alloys have a thin oxide layer that is easily disrupted, especially in high velocity or abrasive environments. And after that, titanium alloys. These titanium alloys naturally form a very strong and stable oxide layer, making them even more resistant to erosion corrosion, and it makes them even more resistant to erosion corrosion than other metals when compared. Hence, These are the common materials affected due to the phenomenon of erosion corrosion. Now let's quickly go through the industrial examples of erosion corrosion. Firstly, piping systems in chemical plants. These piping systems often carry a high velocity corrosive fluid which strips away the protective film, leading to rapid metal loss and leakage risks. And after that, turbine blades in power stations. These turbine blades are exposed to fast moving stream or water, and it causes mechanical impact and chemical attack, especially at edges and surfaces. And after that, heat exchangers. The continuous turbulent flow of hot fluids in the scenario of heat exchangers inside the tubes wears down the oxide layer, and it leads to localized corrosion and thinning of metal. And after that, marine structures. In the marine structures, the scenario of them, the seawater movement and wave action combined with salt and sand particles constantly erode the surfaces and promote corrosion, especially in offshore platforms and ship hulls. And after that, the pumps and valves handling slurries. In their scenario, these handle the mixtures of solids and liquids where abrasive particles cause corrosion and erosion both at a time, while the liquid corrodes the exposed fresh metal underneath. Hence, these are the industrial examples of erosion. Now let's go through the methods to prevent and control this phenomenon of erosion corrosion. Firstly, material selection. We have to use strong erosion resistant alloys that can withstand both wear and corrosion, which reduces the metal loss. And after that, surface treatments. We have to apply coatings or surface hardening techniques to protect metal surfaces from erosion and corrosion. And after that, design modifications. We have to create a smooth, streamlined flow paths to reduce turbulence and minimize wear on surfaces. And after that, operational controls. The lower fluid velocities to reduce the force of impact on metal surfaces must be implemented in order to minimize both erosion and corrosion. And after that, regular maintenance and inspections must be done. We have to conduct routine checks and repairs to catch early signs of erosion and corrosion to prevent further damage. Hence, these are the methods to prevent and control the phenomenon of erosion corrosion. Now finally, let me conclude the topic of erosion corrosion. Hence, we have discussed about this phenomenon of erosion corrosion. This very concept of erosion corrosion itself is one of the critically concerned aspects in many industries, as it represents a synergistic degradation mechanism where mechanical erosion and electrochemical corrosion combine to accelerate material loss beyond what either processes would cause independently. This phenomenon is particularly prevalent in systems where high velocity fluids, often containing abrasive particles, interact with metal surfaces, leading to significant challenges in maintaining the integrity and longevity of industrial equipment. So, the continuous research and innovation related to this phenomenon of erosion corrosion is very essential. Hence, this is the conclusion, the final conclusion of this concept of erosion corrosion. And finally, I would like to sincerely thank the respected professor who had given this wonderful opportunity to me to speak on about this wonderful topic. Thank you.